week, we built this system where we were sending the data from a database back to our client, in our case, our uh, our browser, and the data were nothing but to-dos. So we had the ability to add a to-do or edit a to-do, and so on and so forth. And to do that, for the backend, we leveraged Node.js, and data was, instead of database, we just created in-memory database. Now, this is a good architecture for a simple application like a to-do or a fun project that you're making. But traditionally, real-world applications, they depend upon not just one type of data, but multiple types of data. What do I mean by that? So let's take this example of an e-commerce website which is having the division of uh, different services that you can imagine. Let's imagine that you're going on Amazon.com to buy something. Before you buy a product, you are able to see multiple products of the same type. Let's say you're trying to buy a new laptop. So you can see laptops from all kinds of different brands and all kinds of different configurations. And let's say you like a specific laptop, then you take this laptop and add it to your cart. And once you add it to your cart, you can then go to your cart page, and then let's say you want to now buy two of them, then you're able to update the quantity of your laptop, number of laptops that you want to buy in your cart. Now think of this. The laptops or the products themselves are a different kind of data from the card. And same goes for the billing. Maybe let's say you have a credit card that you've saved in your Amazon. Uh, uh, that kind of the credit card data is also a different kind of data, and they do not typically depend on each other, and they can act independently. What do I mean by that? So let's say you're buying the laptop, and you have the laptop in card, and now your existing credit card gets expired and your bank sends you a new credit card, or you got a new credit card altogether. You can go into your billing database and update your credit card information, and that information of new credit card is no way dependent upon how many laptops you're buying, that is your card, or which laptop you're buying, that is your product. So to keep this kinds of disconnected entities separate, uh, architecture that is known as microservices architecture is traditionally followed in large organizations. We call them microservices, or we call them distributed systems. This is like the crux of backend programming. So when you go out there after, if you once you graduate from the class and do a real world job, more likely than not, you will be building microservices only. You will not be building the entire Amazon.com's backend, but instead you will be working on a team, let's say, who manages the billing, and you will be then building the microservices. Imagine, just in the simplest examples, we have 9 different APIs to get product, search product, or get the product detail, add to cart or update the quantity or checkout. Then for billing, processing payments, generate invoices and payment history, maybe updating the credit card information. So all just in the, hey Marissa, yes, you have a question?
Yeah. Okay, so I just wanted to clarify. So is the microservice, so I see you have the three types of data and the three databases.
Right.
Is is the microservice like for example like the green square, or is it one of the items in the green square, or is it all three of these things?
So microservice is one of the boxes. So product service that you see, like the
Mhm.
green box or the orange box or cart or the purple for the billing, that is one microservice.
Okay.
The inside microservice, you will have that separate APIs, and we will see a code example of this very soon, which will make more sense to you. What are the separate APIs are? But yeah, this one thing is a microservice, and a microservice can have its own database,
Mhm.
or some scenarios, two microservices might be sharing the same database, or they might not have any kinds of database at all. Maybe they are just like row row computing microservice. What do I mean by that? Is like, let's say they just like um like path computing microservice, which just needs some algorithm and doesn't need any dedicated database. But for the simplest form, each microservice has a disconnected relation with other microservice.
Okay. So you're saying all of these are separate, I guess, like items, or they're not dependent on each other, like product service, cart service. They can operate separately.
Yes, exactly. Let's say
Okay.
you in the products, you shut down the billing service, you like
Mhm.
turn off that server. The product service and cart service you still will still work. You still be able to go to Amazon.com and search for a laptop and add the laptop to your cart. The only point you will observe a failure when you actually go to try and process the payment, when you actually after checkout you when they're processing the payment. But till then everything will work. This is the beauty of the microservice architecture that because the entities are disconnected with each other, they do not impact other. So one going down means not entire website will go down. This is this is a core concept of resilience that that comes built with microservice. That is one advantage. And other advantage is, let's say you are like team of 10 developers, and if we did not divide the code into microservices,
Mhm.
one developer changing the code for billing, that code could impact if the same microservices or same code base was used and everything was in a single box, that that might break the product and the cart operations as well. Let's say you change some Node.js dependency, you upgraded a package from like version 2 to version 3, that can break the entire project. To avoid this kind of stepping on each other's toes, as we tell it in the development, right? Microservices also play a big role, and teams can build their services independently and sort of be more resilient.
Okay. All right. Thank you. That was good. Thank you.
No problem. So with that, so let's go back to our previous week's code because it's important to understand previous week's code again. We had a single file where all our APIs were there, and we did not have any logical separation of stuff, which works good for the simple to-do app. But this week we are going to see an example of the version of this e-commerce platform, and I'll provide you this diagram as well, again, just like previously, so that you can have a reference, where our project has two kinds of API. One is for viewing the product, and other is for adding to the cart. Now, this week, another lesson that we need to learn is middlewares. And we looked at the middleware last week, where we were logging a request that was coming in, um, and we were just simply uh, not doing anything with the request, but we were just simply, I think we looked at the middleware the week before, where we were not doing anything, but we were just logging the request. So here, first concept before we go into the e-commerce part, recap of a middleware. So middleware is something that sits between the request that your Node.js server will receive and the response that your Node.js server will send. What do I mean by that? So let's look at the directly the code of this. Uh, Here we have built a simple logging middleware where we log what is the request method, like the method that we have seen, get, post, put, delete, and what is the request URL. And we are just console logging this information before actually going and processing whether user is asking for a product or if they want to add something to the cart. So for all the APIs, for all the APIs and all the microservices that our project will offer, we are using this logger to log basic information. In the real world scenario, this kind of middleware will be actually used to validate first and foremost the logged in users information as well, so that nobody else can impersonate me and buy a laptop on behalf of me. So nobody can like falsely log in into my account and buy a laptop uh, instead of me and send it to their address. So to do that kind of authentication, as we say that, we use middlewares heavily, and we leverage the JSON Web Tokens very heavily. Uh, so let's look at what is happening here. So, and before we jump to, how many of you are still not familiar with the Postman? Actually, I'll describe the Postman really quickly before. Let me just show you. So there is a Node.js project that I have started on Sport 5005, and our middleware is tracking this get call and logging it on the console. So we get at 6:51 p.m. we got a log that this API was called and then the response was received. This will become more clear um, again when we look at one of the um, actual APIs. But before that, real quick. So Postman is something that allows you to build and test your APIs, not build, but actually test your APIs without needing a web browser or a UI. And Postman is quite heavily used uh, in real world developments. So it is important for you guys to understand the Postman as a tool as well. So it's not a complex tool. You go here just like a browser, and then you provide what kind of an API you want to call, and then the URL and any other information for the API. So with that, let's move on to our actual implementation logic. So as we are implementing the product and the cart, so the first thing that we do is And this could be two separate Node.js projects in the real world. Okay, here we are just segregating them into separate modules, but in the real world projects, they would be like completely different, not just projects themselves as well. So let's look at this. So we have something called routes. So this is a route API called product. So when I say my server URL, this is my server URL. This is so localhost 5005 is my server URL. And then we append this thing. This is a route. So server URL dot slash API slash product is a route. Similarly, API slash cart is a route. So this is a routing concept that Express.js uses to separate your different API routes because your project will have uh, tens and twenties or more API routes. You don't want everything to be in the single file, but you want to do group them in some sort of logical manner. So here we are grouping them in either product related routes or your cart management routes. So what does the product related routes handle? So for that we are saying please use this module product routes. And on line 4 we are importing the product route module from a file which lives in our route product.js. So on line 4, we are telling our server, hey, please import a product file, product routes from the file routes products. Now, if we go to routes products, we are uh, defining router.get and a similar router.get by ID. These are very similar to what we did last week, where we were directly saying app.get. Instead, we are calling it as a router because now we are sort of breaking our application into multiple routes, product and cart. So instead of application.get, we are saying router.get and then the function. In the previous project, we defined our function directly in the routes themselves. Uh, this is also not so ideal. It's good for hobby projects and small projects, but in real world projects, you will be breaking the logic of handling the routes into controllers and maybe services as well. We'll talk about them later. I don't want to overcomplicate this lecture. So here I have told my product route to when somebody invokes product slash get. So this API API right now. So this one, I have it here running. So when somebody invokes this API, product API slash product, which is the base route as we call it, when you don't define any parameter, it's a base route. And unless a URL that matches anything, it will always hit the product, the base route. So when this API, the base route is called, go and grab the product details from the function that is defined in the file controller slash product controller. So we have another folder, controller, and in that we have a product controller. So product controller is going back to the our image. It's getting the data from product database. Instead of real database, we just have a JSON file here. which has different products like laptop pro, wireless mouse, mechanical keyboard, and the prices. The product controller is getting all the product and sending them as a JSON. JSON is a standard way of communication between UI and the backend or your Node.js server. And in 99.99 cases, you will be dealing with JSON. So, and JSON is nothing but this is the data structure of JSON, where when I invoke the get all products, I get all the products that were there in my product database, and they are displayed in my Postman. Very similarly, we have defined for our product um, another route of getting a specific product, just like we did it last week of getting specific to do. We have another route which gets a specific product by its ID. So let's say we have this ID in each product P1, P2, P3, P4. We can call products slash specific product ID P1 to get just the information for P1. If I call P2, I would just get the information for P2. So this is our product API, straightforward. It's like you trying to browse all the laptops, and then once you like a specific laptop, getting all the details of that specific laptop. Uh, so this is our product routes. Uh, Before I move to our cart routes and cart logic, any questions here? I'll give you guys 5 seconds to think of any questions so that you guys don't feel pressurized to just immediately ask something. So moving on, this is our product. Let's say you liked a product. Let's say you like the product P2. Now you want to add that product into uh, your cart. But before you want to sort of add that, you want to check what all items are already existing in the cart. So to do that, uh, we built another route slash got what is called slash cart, and the default route gives you API slash cart all the items that are there in the cart, and the data is right now an empty array. But if you had added a product in the cart before, it would appear here. So first API is to get the cart, and again to do all of this, we have defined a separate controller, cart controller, which handles everything in memory. And we have a carts item array. So this is the array that you're seeing here, the one that is defined on line 3. Right now it's an empty array. And when somebody says get all the items in the cart, we simply are returning the array defined in the line 3. When somebody says please add this item on the cart, right? We are taking the data from the request body and appending it to the uh, appending it to our cart array. And we have to also check if the item is already present in the uh, cart. And if not, then only add. So there's some logic that you guys should be able to easily follow through. It's not that important for this lecture, but it's good to have it for the um, complete understanding of the code. But imagine if somebody wanted to add the product. So I am saying I like the product P1. I want to buy one of them. Please add it to the cart. Then our request comes to this item, this route, and this route invokes the function add to cart in the cart controller, which adds provided product P2 into the cart. So let's do this.
Oh, I have a question.
Sure, sure.
Could we go back to the previous file?
The the product one.
It's a different file. It has the add to cart. Lists out all the functions. Okay, here. Okay, wh- so what does JS represent? Because I see we have the file cart.js, and then we have all these, I guess, actions or functions that it can do within cart.js.
Yes. So cart.js represents a route file.
Mhm.
It represents a route file. This is a if you have to logically think all of these dotted arrows are a route that a user of our application, right, can take. So
Okay.
cart.js is representing this route file, which has the definition for this add to cart route, um, update to quantity route, and checkout route. So think of it as, let's say, somebody is coming from mm, Vegas. You're in the States, right? You might be able to follow. Somebody is coming from Vegas and they want to go to LA as well as, and they want to go to LA, but they'll see that there is a one route that is going to San Francisco, and then there is a route that is going to Los Angeles.
Mhm.
Once they figure out that they want to go to LA, that means they have taken the first dotted line of route. Once they have figured out they want to go to LA, then they are identifying where in LA. So LA will have a lot of things, right? So for example, Hollywood. So when you say Hollywood in LA, that is a specific route of LA itself. So once you enter LA, then also you have to take different roads to reach to. Let's say you have a house in LA and then you have a office in LA.
Mhm.
If you're going to your office, then you will take a different route within LA. And if you're going to your house, you will take different route within LA. So those different routes within LA are this function definition.
Okay.
Case the different routes for our carts are get give me all the items that are there in my shopping cart. Now add this laptop in my shopping cart. Then another route for our logic is, hey, I don't want this laptop anymore. Please delete it. So that's a delete route. And then you change your mind. Hey, I want to buy two laptops instead of one. So update the quantity of the number of laptops in my shopping cart. So that's a separate route. Does it make sense?
Yes. Yes, that does now.
Yes. So, and to do all of this, to get all the items into from your shopping cart, to add item to a shopping cart or delete it or update its quantity, we have functions defined in our controllers. And in real world scenarios, these functions could be communicating to databases to update, but we are not using a real database. Instead, we are using just in-memory array to manage our cards. So to do each of this activity, we have function defined, add an item to cart, remove item from cart, and update cart item quantity. So previously we added an item P2, P2 to our shopping cart. Now, before that, we had checked that our cart was empty. Let's fire the same API, and now we see that we are seeing an item in our cart. So let's add one more product. So let's add the laptop as well in the cart. We had wireless mouse, and now let's call again our cart API. This is what happens in the background when you're on Amazon.com and you click on the button add to cart, and on the top right corner you see two, three, four numbers that get updated, right? They are counting the number of items in the array and updating the number. So now we had two items. Now let's say you change your mind and you want to buy two of the mouses, wireless mouses instead of one. You can tell, hey, please update the quantity of P2 item from 1 to 2. And now going back to our get all the items in the cart, we see that from 1, this number of quantity has changed to 2. So for that, this function was invoked, update to cart item, and it landed on this route, route defined on line 17. Hey, please update number of quantities for P2 item from 1 to 2. Let's say you change your mind and you don't want to buy the uh, P1 anymore. Okay, you don't want the laptop, you just want the two mouses. Uh, you fire a delete call with P1 and we get a message item removed from cart. Going back, now let's look at all the items in the cart and we no longer see the P1, the laptop. We only see P2 and wireless mouse quantity 2 in our cart. So these are all the CRUD operations: create, update, delete items in the cart. And these are nothing different from what we saw last week in our to-do example. But here we are doing it in a more sophisticated project, which is an e-commerce platform. And we have not just managing the cart, but we also have the management of different product as well. If you are building this system for an admin user, you could have had a route and a handler to add more items as well. Like let's say instead of just laptops and mouse, you want to sort of sell the clothes as well. But normal users would not have such routes. You are just shopping on a Amazon.com. You are not selling, so you do not have a ability to create new products. So this is a brief example of uh, microservices and how we can structure our code inside an Express and Node.js project so that we achieve a microservice-like architecture with uh, some nice structure around our project. So, any questions on this, or any questions on middleware? If you guys did not understand, you see, in the beauty of it is our middleware is in the background logging everything that we are doing. It is telling us we did post, we did delete, we did get, and all of this. So, any questions on this? So, moving on, one important topic, you will be dealing with the Postman a lot once you become a backend developer or a full stack developer. So, one of the key features that I like is creating new module, uh, and I need to sign up. So, actually, I'll show you guys collections next lecture because I need to create an account. This is not my work laptop, so I do not have an account with them. But look at the collections as well. Right now we are looking at history. It is showing us all the history. So let's say if I had closed everything, I do not remember my APIs, I can go to history and look at different APIs. So this is my card API. So I got it from the history. This is the API. It's important aspect. So this is the post call. I had shown this in the last lecture as well, and I'll show you. I'll tell you again. When you're posting something, this is us. I think the better example is the card. I want to add a product into my shopping cart. This is me telling our server, please take this information and add it into the cart. To send that specific information, there are two ways. When you want a specific detail or a specific information, if you are concerned about updating something in the server, we use post uh, and we provide a JSON payload or JSON data to server. Hey, this is my product, and please add five of them. So we are telling exact details to our server, which product to add and how many of them to add. To pass such information, we use JSON payload. This is one way of sending the information to server. And now let's look at our products API. So this
Uh,
is,
I have a question.
yeah, go ahead.
What is, so I know what JSON is, but what is the difference between JSON and form data when you receive that?
So form data is more built for your form. Let's say you're filling up a form provision. So let's say you'll be having something like a username, and
Mhm.
form is another data structure that sort of browsers use. A lot of APIs are built to support form data.
Okay.
Let's say username, Anuj, and then password. So this is like the checkboxes and the forms that you see in the UI. For the most part, the JSON, so you go row instead of form data. You click on JSON, or sometimes some APIs might take text, but JSON is the most standard. A row data and then JSON, and then you send the data. This is the one way using the body of a post, body of a post to send the data to server. The other is we pass the specific information in the URL itself. Here I'm telling, please give me the product detail for product one. This is also a specific information uh, to send, way to send to the server. So having the information in the server. And in many APIs that you will see uh, a query parameter as well. Product equal to P1. After question mark, you will have you will have an API endpoint, and then you will have a product plus P1. So these are three different ways we can send a specific information to a server to sort of this. We don't have built this route to handle the query parameter, but I believe it's called request.query. Where is that?
So the three ways you said are the query parameter, did you say the param,
Query.
and
This is then
the body?
having having the detail in the URL itself. So like product P1,
Mhm.
and the third is the body. Yes.
Okay.
So that is what I wanted to cover today. We'll talk about the Postman and the collections next week when I get create the collection in the Postman. Will this allow? No, no, it will need me to log in. Okay, I'll create a new account next week and then we can try. But with that, I'll stop sharing and stop recording and floor is open for